Alright, in this video we're going to take a look at bench testing the audio system of a head unit using CHATS with LiveAmp. If you haven't already seen the videos showing how to connect LiveAmp to the target and how to set up the CHATS for bench testing, I suggest doing that first. Otherwise, we're going to dive right in. So, go to the Automation tab. In the top left corner, you can see there is Automatic Mode and Manual. We're just going to keep it in Automatic Mode for this demonstration. If it's your first time coming to the Automation tab, there's going to be these 3 fields that you have to fill out. I've pre-filled them just to save time. Test Definitions Directory, I have selected Bluetooth Wideband 16K. Results Directory, that's just where you want to save your results items. And CHATS Config, so that one's pretty important. CHATS Config contains filter information that is specific to your CHATS hardware. So the loudspeaker plays all audio back through a specific filter. And the CHATS Config also contains ID information that allows LiveAmp to recognize the CHATS sound card within the ACU here. So important to get that one in correct. So if we look down here, if we have selected our folder and there's test definitions in there, they will appear down in the list here. We have some available to us and some unavailable. If we do the unavailable tests drop down and right click on any of these tests, we have show invalidating error. So we'll click on that and it'll tell us why that is not a currently available test. In this case, could not find the intended tap point, voice receive out. So when we get an error like that, it's almost always because we're either not connected between LiveAmp and the target, but I can see that we are. Our button says disconnect here. If it said connect, it would mean that we were not connected. But if we move back to the big picture, we can see that the voice library is not currently active. So in the previous video, we manually started the voice library using the terminal window, but this time we're going to do something different. We have the CHATS Bluetooth unit, the BCU, right here, and we're going to pair that to the head unit and do a simulated phone call to get the audio flowing this time. So what we want to do is open up our Bluetooth window here. I'll just clear this log and bring it in. And if it's the first time opening the window, then you will see that it automatically connects to the CHATS Bluetooth unit. If it can't automatically connect, most likely it's because you don't have the USB cable connected or you don't have the Bluetooth unit powered. So I have both those things. So it says that we are connected on COM4, which is great. Hands-free gateway connection status is not connected. So I want to reset and make discoverable. This just puts the CHATS BCU into discoverable mode. And then from my head unit side, I want to find it in Bluetooth devices and connect. So I've done it before, so I can just find it in my list and hit connect. You can go the other way too, of course. You can search from the LiveAmp side, but I'm just going to do it this way for now. So, okay, we get the message, do you want to pair to QNX car BT? Yes, I do. Click yes on that side, click yes on this side. And we get a bunch of Bluetooth messages in the log, which is great. And we have hands-free gateway connection service level connected. So that's great. That tells us that we're paired. We also get this little Bluetooth icon here, which just further informs us that we are paired. So we don't have audio flowing yet. To do that, we want to make a phone call. So just click Make Phone Call. And then it will do this simulated faked phone call. And there you go. It will tell us that it's ringing and it's picked up, in-call audio. Perfect. But we can see that the audio is flowing by the level meters here anyways. So that's great. That's all we need this for. We're just going to close that window and we're going to keep that Bluetooth connection and that call going for the duration of our testing. So now we want to go and just click this Reload Devices button, and LiveAmp is going to rescan all of the tap points that it has. And you can see when it rescanned, it has taken all of the unavailable tests and put them into the available tests category here because all of those target tap points are now available and audio is flowing. So that's great. So we're going to do a couple of these tests, not all of them, just to save on time. First one is prepare target. We always want to run this before we do our vehicle pre-check or tuning. If we click on the little green triangle here, all this one does is there is a pre-made QCF binary config that basically zeroes out the library. So it turns all the switches on or idle that we're going to tune, and it just flattens out any parameters, values that could have been left on the target. So this will nuke any tunings that you have done previously. So just a heads up there. So we click yes, and then it goes, it restarts, it pushes the binary config over. We see no error message, connection is successful. So that's great, we're ready to go. The next test is also kind of a preparatory test. All this one does is play a noise file to the receive out tap point, which is going to go to the loudspeaker that's connected to the head unit. And we're going to use the CHATS reference mic as an SPL meter to set the playback volume to some level that we want it to be. Now we have it defined here as 65 dB. Doesn't need to be 65 dB. We just found that's kind of a comfortable place to test that. You probably want to set it to the same place every time if you're going to be running multiple tests as your head unit is getting brought up. So let's go ahead and run this. And that's pretty close. So I just cancel as soon as I achieve the 65 dB. I don't need to keep the test going on that one. It's just to get the playback volume set correctly. So always a good idea to kind of keep a similar configuration if you're going to be doing multiple tests over many days or weeks, just because it's going to the reference microphone. So if you move the CHATS further away, you're going to have to turn that volume up higher in order to achieve the 65 dB. So just kind of keep it generally the same. Okay, so the next test, speaker to mic distortion test. So I click go on this. This is going to play a sine sweep from the loudspeaker, the target loudspeaker that we just set the volume for. And it's going to do the analysis on the CHATS microphone and the DUT microphone. Now, the distortion path that we really care about in hands-free is between the vehicle loudspeaker, the head unit loudspeaker, and the DUT microphone, the vehicle microphone. So this is a really important test. So we'll get very quiet when we run it and see what happens. Okay, so it has shown us that we have failed our speaker to mic distortion test. And I could actually hear the distortion on the loudspeaker there. So no big surprise here. If you look at the graph, our green line is the DUT mic. And that one very clearly bumps up over our pass-fail limit, which is the red line. Excuse me. Note on the red line, you can change your pass-fail limit in the test definition itself. If you just open up that file, it's really easy to see what's going on there. This is not a carved-in-stone pass-fail line. It can be whatever you want. It's just a kind of a recommended value to start with. So the CHATS mic is in yellow, and we can see that that one actually did quite a bit better. So if the CHATS mic shows there's not that much distortion, this is strongly suggests that the problem is not necessarily with the loudspeaker, but with the microphone. Because if the loudspeaker were distorting, the CHATS microphone, which is very flat, very sensitive, it would show the distortion as well. So there's some info that can be gained from there. You can zoom in on the graph, right-click and drag to move things around. If you need some really fine detail, you can drop down Show Table. But let's move down to the next graph here. So the next one is distortion, total harmonic distortion plus noise. The plus N there is plus noise. So I'm in a really quiet room, so we're not going to get a whole lot of noise added here. But you can see the fat green line is the DUT distortion plus noise. So there was a noise component added down here. There might have been some noise in the room, squeak in the chair. This is a really sensitive test, so the plus noise portion is anything outside of the harmonic distortion. If a door is slammed while the test is running, you're going to see a giant spike in the noise. So just a word of advice to be really careful, be really quiet while the test is playing so you won't fail the noise portion. Magnitude response. This is basically, it just shows how much of the signal from the stimulus file was present on the DUT mic and on the CHATS mic. Now, we would expect to see a drop off in the lower frequencies like we do here, because the DUT mic, a hands-free mic, typically has a roll-off in the lower frequencies. So that's something that we would definitely expect to see versus the CHATS mic, which is very, very flat. So if you ever see dropouts in the magnitude response, especially on the DUT mic, that could be a bad indication that something's really wrong with the system, because it suggests that none of the playback signal is getting into the mic path. But our system looks pretty good here, pretty strong signal. So show info drops down, just gives us some handy extra details. And then if you want to add a comment on your test, you can put it in there. That'll be saved. Otherwise, let's move on. So let's do a microphone noise floor test. So this one just captures a couple seconds of silence from the DUT mic. So we'll be quiet while we run it. Okay, and this one is telling us that we have passed. I mean, we're in a very quiet room, and the microphone is clearly very quiet as well. Our RMS power is less than minus 60 dBOV RMS, and DC offset is within boundaries as well. These values can be changed to whatever you want them to be. Again, totally not carved in stone. Just open up the test definition file, and you'll find it right in there. Very straightforward to change. Okay, let's do something that plays back through the CHATS. So microphone statistics test. We're going to play a speech file back through the CHATS microphone. It's going to go to the DUT microphone, and we're going to get all sorts of useful information from that. So this one's chopped down just to, the file you'll get will be a lot longer than this one, but just for brevity's sake.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Great, so it tells us that we have passed. It gives us all sorts of information about the recording file, minimum sample and maximum DC offset, RMS power, clipped samples, we have 0%. And, oh yeah, it also takes the LEQ SPL of the full playback. So useful stuff. Last thing, let's take a look at receive latency test and send latency test. So these are really quick tests to do. They just play a noise burst in the receive direction and in the send direction. So receive plays a noise burst over Bluetooth to the loudspeaker, and it measures the entire receive latency path. And the send latency test goes in the opposite direction, plays to the CHATS mouth, to the DUT microphone, and measures to the Bluetooth point. So it measures the entire send latency path there. So let's just run the receive latency test first. I guess I should do a quick note about what happens here. So the test will automatically set switches and parameter values before running. And after the test finishes, it will reset whatever values that you had set before. So just a note that things do change behind the scenes, but they get set back. Okay, so it tells us that our receive path latency is 41.1 milliseconds. And if we run the send path latency test, this one tells us that 87.1 milliseconds in the send direction. So that's pretty much it. We won't run the rest of the tests for now, but that kind of covers the basics of pre-check. And we'll move on to further stuff in the next video.